Good morning, everybody, and welcome to one of my favorite subjects in science. As I was telling you guys yesterday, I love space. I love teaching about space, about the planets, the patterns between the planets. And so this is just one subject that I'm really into. So the focus of this lesson is going to be on the characteristics of the moon, the earth, and the sun. Now, there are some things that they are alike in. There are some things that they are different in. And we're going to be comparing them kind of piece by piece so that you get a good overview of all three of these pieces of our solar system. Now, the first thing that we're going to look at is we're going to look at size. Now, of all three, and you'll figure out as we go that I've put these in order on our 3-column notes for a specific reason based on comparisons of them. So let's talk about the moon. The moon, if you measured its diameter, which the diameter of something such as a circle is the measurement straight across. The diameter of the moon is 2,158.8 miles. Okay. Now let's compare that to Earth. Now, these are definitely not to scale, completely not to scale, but that's okay. Earth's diameter is 7,917.5 miles. So we've got almost 4 times bigger than the moon. Then we have the sun. Now, this is where we kind of go, whoa. Because the sun is 864,340 miles in diameter. So think about this. The moon is about 4 times smaller than the Earth. If we rounded the diameter of the Earth to the nearest thousand, we'd have about 10,000 miles. It would take 860 Earths side by side lined up to get about the diameter of the sun. So that is a huge size difference. So let's talk about temperature, because temperature is definitely very different between these two. The high temperature on the moon is 260 degrees Fahrenheit when the sun is shining on it. And the low is negative 280 degrees Fahrenheit. Now, what this negative means is that you go down to 0 and then you keep going backwards. This is extremely cold, and it gets this cold when the sun is not shining on the moon. So let's talk about Earth. The record high for temperature on Earth is 136 degrees Fahrenheit. The recorded record low, is negative 128.6 degrees Fahrenheit. Now you can imagine that this low was probably recorded in one of the poles, North Pole or South Pole. And the high was probably recorded in one of the deserts on the equator. Now, the sun pretty much stays at one temperature. The sun is generally 9,940.73 hundredths degrees Fahrenheit. Pardon me for coughing. So just looking at these, you know, the lows are more extreme on the moon. The high is more extreme on the moon. And then you go to the sun, and it's just psychotically hot. That's insane. Completely insane. You wouldn't be able to get anywhere near it without basically no longer existing. Now let's talk about gravity. Gravity is the force that keeps us pulled down to Earth. Okay? Now the moon has less gravity than Earth. And the sun has a much greater gravity. So we're going to say much, and I'm even putting that in all capital letters, much greater gravity than Earth. Now, let's think about this. If you remember back in 3rd and 4th grade, when you were learning about gravity, we learned that the amount of gravity on a planet or on a star or in between something is based off of the size of that celestial body. Remember, celestial means it's something out in space, it's in the sky, and body meaning a planet, a moon, a meteor, a comet, a star. So the moon is smaller than Earth, so it's got less gravity than Earth. But the sun is so much bigger than Earth. So therefore, the gravity on the sun is much greater than Earth. And because of the size of the sun emits a gravitational pull around it, which is why all of the planets and all of the moons stay in the orbit that they stay in around the sun. So the sun's gravity keeps all planets in orbit. Okay, and then each planet, based on its size, has a certain amount of gravity pull on things around it, and Earth's gravitational pull is what keeps the moon in orbit. So we'll say gravitational All right, so there we go. We've got size differences, we've got temperature differences, we've got gravitational differences. So now we're going to talk about composition. Composition means what are these celestial bodies made of? Okay, so the moon is pretty straightforward. It's rock. Okay. There are many theories about how the moon came into creation. One of the theories is that a celestial body, whether a comet or something, slammed into Earth and a giant chunk of rock broke off of the Earth and actually split away, and then the gravitational pull of the Earth created the moon and pulled it in, crushed it into that spherical shape. So the moon is simply rock, okay? But Earth is made of solid and liquid rock. And we know that liquid rock is lava, magma, water, and atmosphere. And the atmosphere is simply various gases. Okay. So we go from something very, very simple, rock, to solid and liquid rock, water, atmosphere, various gases. And then the sun is a gas planet, or a gas star made of helium and hydrogen. One of the articles that you will be reading about the sun explains how the sun uses that helium and that hydrogen gas to actually create the heat and the light energy that makes the sun what it is. Okay, so next step is to talk about the layers of the earth and sun. Okay, so to do this, we are going to kind of create a two-dimensional pie cutout of each of these. So I want you to draw basically a shape like that. And for the earth, you're going to have a little ball in the center. And you are going to have another piece here. We are going to be labeling 4 different things on this model. So I'm actually going to grab other colors that we have not used yet. Now, the first thing we are going to label is the crust. And the crust is simply this outer layer. It's what we live on. Okay. The next layer is the mantle. And it's this layer in here, followed by the liquid outer core, which, remember, we said that the liquid rock is like magma, lava, melted rock. And then you have the solid inner core. Okay. So that is the layers that make up the earth as we know it. All right. Now let's take a look at the sun. The sun is a little more straightforward because there's, for our purposes, in some of the articles that you're going to read, it's going to talk about a lot of different other pieces that make up the layers and the composition of those layers of the sun. But there are only 3 that I need you to focus on. So once again, we're going to draw our little cutout. You're going to have that little core. And your second piece. All right, so the first section is going to be called the photosphere. I'm going to try and, let's see here, the photosphere. The photosphere is this outer layer, and the photosphere is what we see. Okay, so in parentheses, I'm going to put what we see. So when you look at the sun, what you are actually seeing is that photosphere. And then underneath the photosphere is the chromosphere. Which is this layer right here. And then in the very, very center, you have the corona. Okay. Now, because the moon is solid rock, there's really not layers to it like the Earth and the sun have, which is why we're not drawing a model for this. One thing I do want you to note for the moon is that the moon is what is called a natural satellite. And and at some point I want you to go on to our class website, because I have the definition for natural satellite there. And I want you to investigate and come up with your own definition to add to natural satellite there. So you're going to need to leave a little bit of space and remind yourself to go back and look at our dictionary to see what a natural satellite is. That is one job that you're going to have for this. Now, I've kind of given you a couple of seconds to catch up on this. Again, you can pause this video and rewatch as many times as you need to, because now we're going to have to move on to the next set of this, which means that this is going to have to kind of be flipped. All right, so once again, let me set up our 3-column notes. And the one thing about these 3-column notes is this is not the only time you will be working with these notes. You are going to be adding to them as you go through the next few assignments. If you find information or facts that you want to make sure you remember, or additions or details, or maybe when you're talking to a friend, you realize, hey, they caught this from that article and I really need to add that to my notes, then that's the purpose of these 3-column notes, is to go back, add to, make them better, and really turn them into a resource that you can truly use to study. All right, so now let's continue taking a look at the next piece. We need to talk about the physical features of these celestial bodies. Okay, so again, physical features is a definition that is on our class website. If you're not sure what physical features means, I highly recommend you go and you dig into that dictionary on our class website and you see what it means. I'm going to go ahead and write physical features under each of these. All right, we're going to start with the moon. Now, first of all, the moon has no atmosphere, which is the reason when astronauts were on the moon, they had to wear masks and oxygen tanks because there is no air to breathe. There is no atmosphere, therefore there is no oxygen. There is no air for them to breathe. Next, it is dry, dusty, and rocky. There are no plants, no animals, no life whatsoever on the moon. It is literally a ball of rock floating in the sky. There are mountain ranges. Just like Earth. There are dark areas. And there are craters. Craters are created when something impacts something else. So you'll learn more about craters as you read through the articles that you're going to be looking at this week. Now let's take a look at the Earth. The Earth has oceans and seas. It has 7 continents. It has lakes and rivers. It has mountains. Valleys. Plains. Beaches. Deserts. Glaciers. Forests. We're also going to add hills up here. So just the physical differences between the moon and the Earth is very striking. That atmosphere that we have on Earth, we can even add atmosphere, allows things to grow. The atmosphere traps heat energy and light energy from the sun. It gives us the oxygen that we breathe, and it allows so much of this to occur. Now, the sun has sunspots, which you'll learn more about with the articles that you'll read this week, and solar flares. Now, this is not the beginning end-all list of the physical features for these 3 celestial bodies, and I did that on purpose. I want you going back and adding to these notes as you read the articles this week. It's even in the instructions to make sure that you are going back, adding to with the information that you're getting. Okay, so one quick last thing is that I want you to have an understanding of the axis for the sun and for the earth, because the axis is what the celestial body rotates on. It rotates on its axis. Now for Earth's axis is not straight up and down. The sun is. The sun's axis goes straight up and down. But the Earth's is tilted. It's not straight up and down. Okay, so we're going to show that it's tilted. And this tilted axis is what causes us to have seasons. So we'll say tilted axis gives us 4 seasons. Okay. And we actually need to go over that as well, but that's going to be in a different video. All right, so this is the end of our basic physical features 101 introduction into the moon, earth, and sun. Again, you'll be adding to these notes as you go through the week and you read the articles. So I hope that this is a good foundation for you. If you have any questions, if you're unsure about something, if it's vocabulary terms, check out our dictionary on our class website. If you don't find the definition that you're looking for there, let me know and I can go back in and add it. That's not a problem. Or if you need clarification on anything, please ask. All right, everybody, have a great day and have a great rest of the week.